Hello, I am Dr. Sigar Kanti, Associate Professor of Mathematics, Government First Grade College, KR from Bangalore. In this video, we discuss some commands related with matrices in scilab. So here we have create matrices A equal to 2, 3, 1, 4 minus 1, 3, 1, 6, 8, and another matrix B equal to 1, 3 minus 2, 8, 2, 1, 1 minus 1, 6. So we have to create these two matrices in scilab. How to create matrices in scilab? I will come to console of scilab. So I will write like this: capital A equals, to create a matrix we have to open square bracket and write the first row elements 2, 3, 1. These are the first row elements. Next, to write the second row elements, we need to put a semicolon here. That is, if I put semicolon, this says that first row ends. Then the second row starts. 4 minus 1, 3. 4, minus 1, 3. Okay. This is the second row. Again, we put a semicolon. Then now we write the elements of the third row. 1, 6, 8. Now close this square bracket. Now if I press the enter button, I am getting, this is my matrix A. Like this we can create the matrices. So here I have taken commas between two elements. Now I will write B equal to, again open square brackets. Here I will give a space, instead of comma I will give a space. 1, 3 minus 2. 1 space 3 space minus 2. Again we put semicolon here. Next, second row 8, 2, 1. 8 space 2 space 1 semicolon. Third row elements 1 minus 1, 6. 1 space minus 1 space 6 and close the square bracket. Okay. So in the first example, I have given comma between two elements. Here I have given space between two elements. Then what happens? Yes, this also creates. That is, here we can give comma or we can give spaces, right? Or we can give the combination of these two also. One comma and another is the space. That also can be done. Now, second question, create a matrix P of order 3 by 4 by taking random elements and find transpose of P. So here random elements, and one command is there to create a random matrix. That command is P equal to, type P equal to, the command is RAND, random. In the bracket, we have to create 3 by 4 matrix. Type as 3, 4. Okay, close the bracket. Now enter. See, I am getting 3 by 4 matrix here. And all these, the elements of this matrix are random. And we can observe that no element is more than 1. All the elements are less than 1, 0.2, 0.3, 0.8, 0.0, 0.7. Okay. So all these elements are less than 1. So this is the command RAND bracket 3, 4. That first one is a row, second one is the column. This creates a random matrix where the elements are less than 1. And here what we need to do, we have to find the transpose. Okay, transpose of P. T, say P, I will name as P here, TP here. Okay, TP is equal to get the transpose, I have to write this as P dash. Okay, this gives the transpose. This is the command to find the transpose of a given matrix. Just P dash. Next, create matrices P and Q and compute something. Okay, create matrices P and Q, compute something. So here P equal to open square bracket 157. So first what I do is I will write 1 comma 5 comma 7. Second row elements we have to put a semicolon here. Second row elements 7, 8, 10. I will give spaces here. 7 space 8 space 10. Okay, again put semicolon. So first row elements I have separated by comma, second row elements I have separated by spaces. In third row what I do is 1 comma 1 space. That is third row is 0 comma 1 space 5. Okay, close the square bracket. See, this is the mixture of commas and spaces. Enter. Press the enter button. Here, in this case also I am getting the answer. So that means we can do commas or we can do spaces or we can do mixture of commas and spaces. This is our P. And Q is Q equal to open square bracket 7, 8, 10. First one is 7, 8, 10, semicolon, 15, 1, 2, 15 space, 1 space, 2, 15, 1, 2, semicolon, 3, 7, 5, 3, 7, 5, close the bracket, square bracket, enter. I am getting this Q. Now we need to find out these P plus Q, P minus Q like this. Okay. So first one, just you type P plus Q. P plus Q. This adds these two matrices. Press enter. I am getting P plus Q. P into Q. P into again star here. Q. Enter. Okay. P minus Q. P minus just Q. P minus Q. This is P minus Q. P to the power of minus 1. P to the power of. Okay, I will give a cap here. Just I will try. P to the power of minus 1. I am getting something here. Now if I write this, what happens? INV of P. Are they same here? Yes. That is P to the power of minus 1 means it is nothing but inverse of P. P square. P. Let me write like this. 2. I am getting this thing here. P double star 2. Okay. P cap 2. What I am getting? This is also same. Yes. And I will write P star P. This is also same. Yes. That is here. P star P. Or we can add P cap 2. Or we can add P double star 2. Double star used to raise the power. Okay. Next. 3P plus 4Q. 3P plus 4Q. That is 3P plus 4Q. Okay. 3P. That is we have tried 3 star P plus 4 star Q. 3P plus 4Q. Press the enter button. I am getting 3 into P plus 4 into Q. Next example, 5P square plus 7Q square. 5 star P square. P power 2 5P square plus 7Q square plus 7 star Q power 2. Q cap 2. Enter. Yes, this is 5P square plus 7Q square. Now P dot Q element wise multiplication. Let me write P star dot Q. Sorry, P dot star Q. I am getting something here. Oh, what is this P dot star Q? What is my P here? So again, my P and this is my Q. If I write P dot uh, star Q, okay, what I am getting here? What is this matrix? This is the matrix. See, this is my P, this is my Q. What is 1 into 7? 7. 5 into 8? 40. 7 into 10? 70. 740, 70. 740, 70. Yes, I am getting here. So that means here P dot star Q is the element wise multiplication. Corresponding element multiplication. Okay. Next, P dash plus Q dash. P dash plus Q dash. P dash plus Q dash. That is the P transpose plus Q transpose. So this is my P dash plus Q dash. Next, another example, 3PQ dash plus 5QP dash. 3P, 3 star, P star, Q dash, Q dash plus 5 star, 5 star, Q star, P dash, P dash. Okay. Sorry, this is a star, star. Okay. Now enter. Yeah. This is our 3PQ dash plus 5QP dash. Okay. Next example, construct A equal to a matrix, this matrix, and B equal to another matrix, display something is there. Okay, first I will construct the matrix A, fourth one. Yeah, first I will construct the matrix A. Okay, so A equal to matrix 5 minus 3, 2. 5 minus 3, 2, semicolon, minus 6, 10, 7, minus 6, 10, 7, semicolon, 2, 4, 1, 2, 4, 1, so square bracket close. This is my A. What is B? B is here, B equal to, open bracket, 4 into 2. We can give expressions also in the elements here. 4 star, automatically it will take as 8 here. A second element is 2 by 3. 2 by 3. This is first row. I have to give semicolon. Second row is 1 by 205 space 5 minus 7.8. 5 minus 7.8 semicolon. Sorry. Third row 0.0001 space 9 plus 8 by 50. So I have to put a bracket here. 9 plus 8 bracket close divide by 50. Okay, 50 bracket square bracket close, enter. Yeah. So these are my A, B. Okay. We have to display A, 2, 3. That is second row, third column element. Second row, third column element. This is equal. Second row, third column element. This is 7. Then I have to display this 7. For that, the command is, my matrix name is A. A. Open bracket here. Just give us 2, 3. Bracket close. This gives 7. That is the A23 element is 7. B32 similarly. B I have taken capital here. I have to write capital B open bracket 3 comma 2. 3 comma 2. Okay. Enter. This is 0.34. That is third row second column element. Third row second column element is 0.34. Like this we can access the elements here. Next, row 1 of A, that is first row of matrix A. The command is A, open bracket, first row, give 1, comma, 1 comma, colon, bracket close, 5 minus 3, 2. Is this the first row of A? Okay, let me check. Yeah, 5 minus 3, 2. So we have to give us A 1, comma. If I write any element here, say 2, then that gives element in the first row, second columns. I am giving this colon means take all the columns. First row, all the columns. So that is first row, all the columns. 5 minus 3, 2. It is displaying. Column 1 of A. Column 1 of A. So that is I have to write this A, open bracket, all the rows. Column 1 of A means all the rows. So I will write this as colon, comma, which column I need? First column 1. Okay, bracket close. This gives all the rows and 1 column. All the rows, 1 column means 5 minus 6, 2. Okay, just I will press the enter button. I am getting 5 minus 6, 2. Next, row 2 of B. So that is here. I have to type as capital B, open bracket, second row. I will type 2, second row, comma. Which element? All the elements, all the columns here. So that means here I have to write colon, bracket close, B2, second row. This is our second row of B. Once again check here. This is the second row. Okay, I am getting second row here. Okay, next one is fifth one. Create matrices A, B, C and compute something is there. Okay, let me create these matrices. Matrix A equal to, open square bracket, first row 1, 1 by 2, give a semicolon. This first row. Second row 1 by 3, 1 by 4. 1 slash 3 space 1 slash 4. Second row over, give a semicolon. Third row 1 by 5, 1 by 6. 1 by 5 space 1 by 6. Close the bracket. Okay, just enter. I am getting this is A. This is a 3 by 2 matrix. And B equal to, capital B equal to, open square bracket here, 5 and minus 2. That is here. Only one row is there. That is here. 5 space 2. Close the bracket here. Okay. This is our 5 and 2. 5, 2. And C is the matrix equal to, open square bracket. This is 2 by 3. 4. Second element is 4 by 5. And 10 by 7. 10 by 7. First row is over. Give a semicolon. Second row 1, 5, 6. 1, 5, 6. Bracket close. Enter. So this is our C. Compute the following. What to compute? Okay. If defined is given. Okay. If they are not defined, then it will give some error there. Okay. A star B. First one is A star B. A star B. Enter. Okay. It's not possible here because what is A? A is, what is the order of A? Order of A is 3 by 2. Okay. B must be of order 2 into something. It is 1 by 2. Okay. This is not defined. A dot star B. A dot star B. Okay. Enter. Again, inconsistent row, not defined. Next, A plus C dash. Yeah, this is defined. Next, B star A minus C dash star A. C dash star A. C dash star capital A I have to write because capital A, small a, they are different. Inconsistent row. Okay. Then 2 plus, this is 2 plus C minus 6 star A dash bracket close. Okay. No need to take the bracket here. Okay. If you put bracket also, then no problem. Yeah, this is also defined. What is the meaning of this 2 plus C? 2 plus C? See here, let me check. What is my A? So A is this. If I take 2 plus A, what I am getting? See, I am getting these quantities. From this, we can understand what is this the meaning of 2 plus A. Okay. In general, 2 plus A, this is a number, this is a matrix, 2 plus A is not defined. But in scilab, it is defining what it is doing. 1 plus 2, 0.5 plus 2, 0.333 plus 2, 0.25 plus 2. That means here, this 2 is added to each element of A. Whatever may be the size of A, 2 is added. Okay. Automatically, this becomes a matrix of order as that of the order of A, whose elements are equal to 2. That is the meaning. Next, this one A star C minus C star A. A star C minus C star A. Okay. Yeah, this is also not defined. Next, A star A dash. A star A dash plus C dash star C. A star A dash plus C dash star C. Okay, enter. This is also defined. Next example is create 5 by 4 unit matrix. So in scilab, there is a command to find the unit matrix. Unit matrix and identity matrix. That is, here we take unit matrix means matrix consisting of all the elements equal to 1. I will call that as unit. Identity matrix is our usual identity matrix, identity element. Okay. So here to create 5 by 4 unit matrix, I will put ONES open bracket 5 comma 4 bracket close. ONES 5 comma 4. If I enter, what I am getting? See, I am getting 5 by 4 matrix whose elements are, all the elements of this matrix are equal to 1. So this creates ONES bracket 5 comma 4 means this creates a matrix of order 5 by 4 whose elements are equal to 1. Zero matrix consisting of all zeros. Same method here. ZEROS. This is the command in scilab. Open bracket. Give the order here. 5 by 6 I need. So 5 comma 6. Close the bracket. Enter. I am getting a zero matrix whose order is 5 by 6. 5 rows and 6 columns. 6 by 6 diagonal matrix. 6 by 6 diagonal matrix. The command is DIAG, okay, bracket 6 comma 6 bracket close. See, this is not the diagonal matrix. Okay, this is 6 by 6 matrix, but here the element is here. The 6 is here, but I want the element 6 here. So that is on the principal diagonal 1, 2, 3, 4, 5, 6, 7. And here the 7 1 2 3 4 5 6 7 1 2 3 4 5 6 7 by 7 matrices, they are not 6 by 6. That means this has some different meaning. For this, what I do here is I will write it like this: DIAG, open the bracket, within that type 6 elements here: 1 2 3 4 5 6, and close this square bracket. Okay, and again close this parenthesis. Now just enter, press the enter button. I am getting this thing here. Here 1 2 3 4 5 6, 1 2 3 4 5 6. Okay, 6 by 6 matrix, and this is a diagonal matrix. See that DIAG, open bracket, within this square bracket, whatever we give the elements here, they will be put on the principal diagonal, and correspondingly the matrix is created. So here I have given 6 elements, 6 by 6 matrix is created. If I give only 3 elements, so that is here, if I okay, so this is this consisting of only 3 elements here. Just enter here. See, I am getting here 1 4 6 on the principal diagonal. Corresponding matrix is automatically created. What happened when I give 6 by 6 6 comma 6? That means here, okay, to this I will do one more thing. If I put comma here and if I put type 0, what type of the matrix I am getting? I am getting the same matrix here. Let me try for by typing 1. What happens to this? Yeah, now I am getting some different matrix here. That is 4 by 4 matrix I am getting. And here these 1 4 6 are not on the principal diagonal. They are one line above the principal diagonal. This is my 1. Okay, can you understand? 1 4 6 are not on the principal diagonal. These elements are one line above the principal diagonal, and correspondingly the 4 by 4 matrix is created. To understand this more, if I type 2 and enter, I am getting one more matrix here. See, this is the matrix 1 2 3 4 5, 1 2 3 4 5 by 5 matrix. Okay, and where these elements are 1 4 6, this is the principal diagonal. Okay, and this is the line 1 above the diagonal. This is the second line above the diagonal. This is my 2. Okay, similarly, if I write 3 and enter, what I am getting? 1 2 3 4 5 6 by 6 matrix I am getting here. And the diagonal element, this is the principal diagonal. Above one diagonal 0, second line 0, third line I am getting 1 4 6. So that means here, whatever the number we give here, these elements will be put on that line above the principal diagonal, and corresponding size of the matrix is created. What happens if I give this as say minus 1? According to this, these elements must be one line below the diagonal. That 1 4 6 must be one line below the diagonal. Enter. Okay. See, 1 4 6 are one line below the diagonal. Similarly, if I give minus 2 here, enter. See, these elements 1 4 6 are second line below the principal diagonal. This is the principal diagonal, first line below. This is second line below. Similarly, if I write minus 3, enter. See, 1 4 6 are here. This is the principal diagonal. This is one line below. This is second line below, and this is third line below. So if I give negative sign here, these elements will be put on the line below, that third line below the diagonal. If this positive, above, if it negative, below. Okay. Diagonal matrix. 6 by 6 diagonal matrix means we have to use 6 elements. Okay, in a square bracket. Just we have to Keep that as it, nothing to give. That is 0, 1, 2 is not necessary. Just if I write DIAG open bracket, close bracket, within that square bracket, you have to give 6 elements there. Now they create 3 by 3 random matrix. That is RAND 3 by 3. That is 3 comma 3 comma 3 bracket close. Enter. Bracket close, enter. Yeah, this is 3 by 3 random matrix. Okay. 3 by 3 random matrix. Okay. 4 by 4 scalar matrix. How to create scalar matrix? It is a identity matrix where the diagonal elements are 4. I can write like this. 4 by 4 scalar matrix. Say 7 star EYE bracket 4 comma 4. Okay. What this gives is, this creates a matrix of order 4 by 4. That is identity matrix of order 4 by 4. In this, elements on the diagonal are 1, 1, 1. I am multiplying by 7. So that means here all the elements on the diagonal becomes 7. This is the scalar matrix. Okay, this is the scalar matrix. Or you can create like this also. DIAG open bracket within square bracket 7, 7, 7, 7 close square bracket close this bracket parenthesis. This also gives, okay, 6 by 6 identity matrix. Identity nothing but EYE. EYE. Okay, 6 comma 6. 6 comma 6. Identity matrix. What happens if I give just 6? Answer is equal to 1. So I am not getting 6 by 6 matrix here. Tri-diagonal matrix. Tri-diagonal matrix means diagonal elements are non-zeros. 1 above the diagonal are non-zeros. 1 below the diagonal are non-zeros. I have to give this as the sum of the 3 diagonal matrices. That is DIAG bracket 6 by 6 tri-diagonal. Okay. Here I will create one diagonal matrix. 1, 2, 3, 4, 5, 6. Close the bracket. This creates 6 by 6 matrix where these elements are on the diagonal. Plus, what I do is I will create one matrix of order 6 by 6 where one line above the diagonal are non-zeros. That is DIAG bracket open square bracket open. Here I will give only 5 elements because 1 above the diagonal means 5 elements. 5 element space is there. 1, 3 elements, 4 elements, 5 elements. Okay, close. Here I will put these elements 1 above the diagonal. So I have to give 1 here. Bracket close. Plus, and I will create one more diagonal matrix where 5 elements are one line below the diagonal. That is again 6 by 6 matrix I am creating. TIAG open bracket open this square bracket. Within that I will give 5 elements here. 4 some 5 2 3 4 5 bracket square bracket close comma. I had to minus 1. Close the parenthesis. Now enter. Okay. So I am getting, this is the matrix 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 by 6 matrix. Here diagonal elements are non-zeros. 1 above the diagonal are non-zeros. 1 below the diagonal are non-zeros. This is known as tri-diagonal matrix. Next one is 4 by 4 diagonal matrix with diagonal elements 5. So that is just we have to write diagonal matrix 5 means it is nothing but a scalar matrix. I have to give 5 star EYE, open bracket. What is the size? 4 by 4. No, yeah, just give you 4 comma 4 bracket close, enter. So this is the 4 by 4 matrix where all the diagonal elements are 5. Okay. And the 7 one is create a 4 by 4 random matrix with random elements between 0 and 36 and find something. Okay, first I will create a random matrix. So that is, I will write this as A equal to matrix. See, just if I give random, it creates a matrix whose elements are less than 1. Therefore, to get the elements up to 0 to 36 random matrix, I have to give this as, I'll write this as 36 star RAND open bracket 4 comma 4. See, this creates a matrix. This creates a random matrix of order 4 by 4 where each element is less than 1. Okay. If I multiply this by 36, then each element is less than 36. Okay. If I enter, see, I am getting this is the matrix. This is the random matrix whose elements are between 0 and 36. Square of the matrix A square. Okay, this is your A square. Element by element square. Element by element square. That is here. Element by element A dot star A. This element by element is multiplication. Okay, square is there now. A into A. Okay, that gives A square. Right? A element by element. A11 into A11. That is A1 square. Okay. And next one, trace of the matrix. Command is trace. TRAC open bracket A close. Yeah, this is the trace of the matrix. Eigenvalues. The command for eigenvalues is SPEC. A. Okay, enter. These are the eigenvalues. 4 eigenvalues. Maximum value MAX command is, write the matrix name here. A. I have taken small a. Max A. This is the maximum value of the matrix A. Minimum value MIN in the bracket A. Enter. This is the minimum value. Sum of each column. The command is sum open bracket of which matrix A, comma, column. I have to give this column as in single quote C, single quote close the bracket. So this is the sum of each column, sum of each row. Similar command sum open bracket A, comma row. I have to put this in a single quote or single quote close the bracket. Yeah. Sum A R. Sum A comma C. Okay. Space is not there, therefore it is given like this. If I extend this one, yeah, I am getting like this. Next one, sum of each row is over product of all elements. Product of all elements The command is prod a, enter. This is the product of all the elements. Display third row. Display third row, that is a, open bracket, third row 3 comma all the columns colon, close the bracket. This is the third row. Okay, this is the third row. This is the third row. Okay, thank you. I will stop here.